Hello, everyone. Welcome to our first workshop of the fall term and of the academic year. This is a workshop a bit different than the one that we have done in the past, kind of like not like the traditional. We're just going to go over the basics. We're just going to go and take on a project. And if we sent a PDF before, hopefully you looked at that if you like don't have exposure to Python, but if you are stuck with something and have a question, we have a lot of people in this call that can help you out. So please, you can unmute yourself and ask a question. We don't mind it at all, or you can just shoot out the question in the chat and we will make sure to respond to you. Now, this is going to be a workshop. We're going to go over a project, how to solve Sudoku, and it's going to be presented by Chris and to Bernard, and I wish good luck to both of them. All to you, Chris.
All right, thanks, Ray. Hi, everyone. Good morning. Hope you guys are having a good fall term, a good start. This will be my first workshop, so please bear with me if there are any serious problems. I certainly hope not. Um, just want to comment. We have a really good group of people today. A lot of different majors, not just electrical and computer. I saw we have some biomed engineers. We have a business analyst major, mechanical. So we got a really good group for this workshop, and I'll be really excited. Um, introduce myself. I'm Chris. I'm a pre-junior in electrical engineering, and Bernard is with us as well. Bernard, do you want to quick introduce yourself?
Yeah, sure. So yeah, I'm a computer engineering and I'm a junior. And yeah, I'll be co-hosting with Chris later on.
All right. So let's get down to business. So the goal of this workshop is to use basic built-in functions in Python in order to solve Sudoku. So we're going to go through some of the basic functions such as for loops, kind of how to build a Sudoku board, like the matrix that you see on the board here. Oops. We're gonna discuss how we can use Python to make, we'll call it a list of lists, and we'll get into that in greater detail later. Um, but we're gonna learn a bit about how Sudoku works and how we can use a recursive algorithm to not only better understand Sudoku but also solve it very very quickly. Um, and if you don't know what Sudoku is, that's okay. We'll get to that. It's a really fun numbers game, um, and for the actual coding portion of the workshop, I'll be going over how to create the Sudoku board, printing it out, and dividing each of these 3x3 sections in this overall 9x9 square. And Bernard will be going over the recursive algorithm that actually helps us solve for all these empty squares here, which we want to fill in. So we have a poll that we want to share, just asking everyone if they have experience with Python, just so we can kind of get a gauge of how much people know, so we know how much to really get into the syntax and basics, which we're not using any like additional libraries. We're not using NumPy. We're not using anything like that. So you can really use any IDE that you are comfortable with. So actually, in the chat, I just want to ask, and you can type, yes or no. Does everyone have um, at their computer or laptop? Do they have access to uh, an environment or a shell or an IDE that they can type Python code? That can be Spider, that can be PyCharm, it could be a REPL. Yeah, and there's a link to Bernard just posted it, REPL.it, and you can use that to get into a Python environment. Okay, looks like a lot of people are saying yes. And if you don't, that's okay. We're here to help out. But it looks like so far Everyone is saying yes, so that's great. That's good. Okay. All right, Liu Yang is trying to download one. It's okay. We're going to be going over the basics. If at any point you need us to slow down or you just need a moment, and that goes for everyone. Always feel free to type in the chat or unmute your mic to ask a question if we're going too fast or whatever. We'll have a feedback form at the end for those kind of things. Yeah, I would recommend using repl.it if you don't already have something downloaded. Thank you, Bernard. All right, poll is in. Most everyone has voted. Looks like majority of people have some experience or just the basics, and that's good. So we'll talk about the basics briefly right now. The kind of like the building blocks of how we're going to piece together our code. And then later on during the code, we'll go into greater detail and kind of show some examples as we build our codes. So an important thing in Python and in a lot of coding languages is the idea of the for loop. So for some condition, this will happen. And you have a for loop and then you indent, like so right here, for I in range of start end. So it basically iterates. So let's say you want to iterate your code or run through your code 10 times in a range from 0 to 10. That's what a for loop would be good for. And a nested loop, all that means is that within our for loop, we can have other loops too. And again, we'll get into greater detail with that. If you ever have any questions about what that means or how to show that, we'll get to that. Functions. We're going to need to define some functions in our code. And a function is something that we can call on later. It's basically a block of code that runs some sort of calculation or takes an input or an argument and uses that variable in your code, whatever it might be, and you can call on it later. It doesn't have to return anything. You can just define it, and then later on the code, it could be thousands and thousands of lines down in your code. You can call it again, and you can use it. It is it's a user-created function because things like the print function, where we can print a string or a variable, those things are built in, but those are functions, but they're not user-created functions. We can actually define our own, and that's a really useful thing to have in your kind of coding repertoire. And then there's also the concept of the modulo or the modulus, which will be really useful for actually visually creating our board when we run our code. We can use this to basically every 3 rows or 3 columns in our matrix, we can divide it with lines or some other symbol. But a modulus, for anyone who doesn't know, a modulus returns the remainder. So 5 modulus 2 would have 1, because 5 is not divisible by 2. If you were to divide 5 by 2, you'd have 2.5, but you don't. So what you get is 4 divided by 2, and then there's that remainder of 1. And if that's confusing to anyone, it's okay. Feel free to ask. But we can move on for the moment. Sudoku, if you don't already know, it's a number game with 9 squares of 9. I'll go back to here. You see that we have these rows and columns of 9. And in each of those rows and columns, we want to have the numbers 1 through 9. And they can be in any order, but they cannot repeat. They could repeat in columns. The columns don't matter, or the diagonals. So see here in this first row we have 1, we have a 2. So the rest of these squares, they could be anything from 3 to 9. But whatever we fill into these squares, they also can't be in a row with that or a column with that same number. So that's what's going to make this whole recursive algorithm idea really, really important. And Bernard will really get into the the details later. But we don't want to have to, in our code, fill out this entire board, fill in all these empty squares, and then at the end, check it and say, oops, we have mistakes, and then start all over again. Because there are so many possibilities. It would take a very long time to do that. So what we want to do is we want to basically go one at a time, and each time check. And if there's something wrong, backtrack. So that'll be a really important concept. But that's essentially what you do when you play Sudoku by hand, is you fill it in with your pencil, and you go a couple squares at a time, and you're always checking the rows, checking the columns. And sometimes it requires you to backtrack quite a few steps. But when we do it through Python, it's a lot quicker because we don't have to write it down with a pencil and try and keep track with our heads. Yep, like I said, 1 through 9, no repeats. Oh, and each 3x3 square. Each of these squares also must have 1 through 9. That's a very important thing. I don't want to forget that. So you can't have a 1 here and then a 1 here. That's a big thing. I almost forgot about that. And I'll let Bernard take the rest.
Yeah, so how do you create a matrix in Python, right? So there's like a couple ways of doing it. One way is to import like an external library called NumPy. But the way we're going to use today is going to be just implementing a list of lists. So what I mean by that is that each of these elements of the board list is actually a list. And so if you access, can I get the next slide? If you access the list by the row, then it would return the element list, and then you can access the column with another index access syntax thing. So right here, we're trying to access the position 0, 0, which would be 1. So first, we're going to put the first x coordinate as 0, highlighted in blue, and then the y coordinate would be highlighted in black. So next slide. So as we call it, board 0 would return the list 1, 2, 3, right? And then that the Python views it as shown on the right hand side here. And if you index it to 0, then it would return the number 1. So that's how we're gonna access the matrix, the elements in the matrix. So here are a couple more examples. The row, remember the row comes first, so 2, and then the column would be 0. Then another one, I think. So the row would be 2, and then the column would be 2 as well, meaning that it's 9. Oh, and because it's Python, we start the index at 0. So it would be 0, 1, 2. That's why it's not like 3, for example. It would be 0, 1, 2. So 0 to 2 for this 3x3. All right, so here's just a demonstration of it working. And you can print it. You can do whatever you want with it because it just returns the integer inside of that matrix. All right, so now we're going to talk more about nested for loops. So how do you iterate through a matrix with the code, right? Well, we're going to make a for loop, a big for loop with for the row, and then we're going to make another one for the column inside of that row for loop. So we need 2 for loops to go through. So here's an example of that. It's just a very simple. It's declaring the board matrix, and then we're going to iterate through the rows and then the columns, and then we're going to print each element. And then so it would print each element of the row, which are the columns first, because the column for loop is nested inside that row for loop, right? And then at the end, after it's finished printing each element in the row list, it would print a new line so that we start printing it on the next line, like 4, 5, 6, and then it would do the same thing for that line, and then eventually it would print 7, 8, 9, as you can see on the left there. All right. So I'm going to explain briefly about recursive functions because we're going to be talking about them right now. So just keep this in the back of your head when Chris is coding, because this is like the main function that's going to be solving our Sudoku problem. So a recursive function is basically a function that calls itself. And there are two parts to a recursive function. There's a base case, which when you're calling yourself, you want to be able to escape somehow. So that's exactly what the base case is. It's just comparing something, and if it's satisfied, it will leave that function call, right? And then the second part would be the recursive call, which is the thing that actually calls the function itself. And there are a lot of advantages to recursive functions. For example, iterating through like a brute force method with a bunch of loops and doing stuff like that would actually take longer, or like be more complicated code than just a recursive function. So it has very specific applications, and a Sudoku solver is one of them. So this way we can keep our code short and be easier to understand. All right, so Chris is going to now explain how to actually code, and I encourage you guys to follow along with your favorite IDE, no matter what it be. And so, Chris.
Yeah, thanks, Bernard. All right, I'm just gonna really quick make sure I have Spider open. Okay. Make sure I'm zoomed in so you guys can see, and I will click share my screen. Okay. Is everyone able to see the interpreter? They're able to see the lines on the right and the console on the bottom right?
Yeah, I can see it.
Yes. Okay, awesome. Okay, so we talked a lot about a list of lists and how we can make that into our Sudoku matrix. So we'll just start by, and this is just an example. This won't be like a full 9x9 board. Let's just make a list of lists. Let's call it board. And these square brackets denote that we're making a list. Let's make a list of 3 lists, and each list has 3 variables. 4, 5, 6, 7, 8, 9. Now, the way we can call from this, like we described in the PowerPoint, is by using the rows. We're calling them the rows and the columns of our matrix. But what we're really looking at is we're looking at each of these individual lists within the larger list called board. This first list is index 0 of board. This second list is index 1, and this third list is index 2. And again, don't get confused by the 0, 1 through 2. Oh, hold on just one second. Make sure I have the Zoom chat pulled up. Oh, there it is. It's on the side. A tuple, we will actually be using tuples later because a tuple is immutable. So we want to be able to... Actually, I don't know if a tuple would negatively affect... Actually, no, it would, because we're going to be taking our board that we're going to be making, which our initial Sudoku board, remember, it has those spaces, or we can put zeros in place of those spaces. We'll need to put in the new numbers into that board. So if it was a tuple, we wouldn't be able to change that. we wouldn't be able to change the list in the tuple. We need to be able to replace those zeros or those spaces. We need to be able to replace them with the new numbers. But we will be using a tuple just to reference the locations, the row and column locations. But the actual board itself is a list, so we can actually add and remove the numbers as we go through the algorithm later. Does that answer your question, Emre? Okay. So board 0, 0, if we print that, it's going to give us, should give us, a 1. Because we're looking at this 0 here, our row, because we're going row and column. This row is index 0 of the overall list of lists, and then index 0, and then the column is index 0 of this list. So 0, index 0 of the overall board, and then 0, the index of the board that or the list that we're referencing. I just wanted to get that out of the way, just so we don't get too confused by later on in the code when we use I and J to kind of represent the rows and columns that we're indexing. So I'm just gonna really quick pull in a 9x9 uncompleted board. So this is what we would start with. We would start with a list of lists with 9 lists, and each list has 9 values. I just pulled it out from a separate text file I have to help me along with the process. Yes, thank you, Bernard. That's this. You can copy and paste what Bernard pasted in the chat if you want to use this exact same board. This board has already been checked to make sure that there's no repeating 7s or 8s or anything. No, this is just a manually put in one, but that would actually be a really good implementation to create randomly generated boards. That's a really good idea, Akshat. So we understand our list of lists concept now. Let me just expand this a bit. Okay. So we want to print this board out, and we can see that it's 9 lists, each with 9 indices, and it looks kind of like a board, but we don't have all those separations. So in that Sudoku board, we had the horizontal lines separating every 3 rows and the vertical lines separating every 3 columns. And we don't have that here. So visually, that makes it really difficult to kind of figure out where each number is and where they should be. So we want to create a function that will print out the board and create those separations for us. Yes, good point, Matt. So we'll start by defining a function, which we start with def for define, and we'll call it print board. And we're going to have an argument in this print board function, and we're going to call it bo, just shorthand for board. Bo is just a placeholder. We can put anything in there. In our case, we're going to be, when we call this function later in the code, we're going to be putting in board, but bo is what we'll use in the function to kind of reference that, like, hey, this is where our argument's going to go. Like if you're making like a calculator, that might be like number 1 or number 2. Yeah, you could also call it a parameter. I think that'd be a fair like synonym. If that's incorrect, someone can correct me on that. So how are we going to go about printing our board? We're taking our variable bo, and our variable is going to be a list, in this case our list of lists, and we need to create a function that for every index in the length of our board, and length is basically just the number of indices of our board, which we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of. For every index in the length of our board, we need to be able to iterate through each of those. So we can say for I, and I indented here to indicate that we are within our function. Python uses a lot of indentation to kind of show that it's within something. So for I in range of the length of BO, which remember is a placeholder for our board, if I modulus 3 equal to 0. So what we're doing here is we want to start off by splitting our rows in every 3. So this is saying that for I, which I will basically be in our rows, if you remember, if you're calling board, row, column, we'll be using I and J to denote our rows and columns. So for every 3 rows where we want to input a horizontal line, so we can do that by using modulus. Yes, within the code it will be BO IJ. Thank you. Yes, it will be BO within our code. And just remember that could be anything. We could name that anything, but we'll use BO for shorthand. So yeah, so we can use the modulus to show when our row is divisible by 3, and that's only going to be possible if the indices is equal to 3, 6. 3 and 6, because since we have 9 rows, we're going to have indices 0 through 8. So if the row indices modulus 3 is equal to 0, meaning there's no remainder, and I is not equal to 0, because we don't want to have a horizontal line printing out before we even start showing our numbers. Then we'll print a line, and this will be our divider line. Is everyone clear so far? Is this making sense? You can just type yes or no in the chat or turn on your mic.
Yeah, this is making sense.
Okay.
I have a question actually.
Okay, sure. What
So
is it?
you mentioned that it only goes up to 8.
Yes.
So would the fact that it starts with 0, 1, and 2, would that like mess up the modulus 3 or not?
Yeah, so 0 modulus 3 would give you a 0. 0 divided by a number would give you that remainder of 0. So when we're saying I modulus 3 is equal to 0, that's it, a modulus gives us the remainder.
Okay.
Yeah, so if we had a 0, it would print out this line before we started printing out the numbers in our Sudoku board.
Oh, okay. So it goes above each.
Yeah. So
Okay.
this will print out in between. So you'll have indices row 0, row 1, row 2, and then when we reach row 3, we'll print this out, and then we'll continue. Row 3, row 4, row 5. We reach row 6, we print this out. 7 and 6, 7, and 8.
Okay. Gotcha.
Yeah.
Thanks.
All right. Any other questions before we move on?
I have a question.
Okay.
So when you say the length, it's only going to take account the rows, right?
Yes.
And so the range is going to be from 0 to 9.
Range, yes. 0 to 8. Yeah, it's 0 to 8 because Python starts at 0. So there are 9 rows. You're correct. There are 9 rows. But we're counting 0 as a row. Row 0, 1, 2, 3. It's a little confusing, but it's 0 through 8, which are 9 rows, if that makes sense.
Oh, okay.
Yeah.
We start counting at 0.
Can I speak on that too?
Sure.
So length BO, I think that will return a 9, but the range function that we're using there is it's gonna return like kind of like a range from 0 to 8 because it doesn't include that end value. if that makes sense too.
Yeah. Would you like me to show a quick example of like just printing out the length of a number and then the range of that number?
Oh, no. I get it, but thanks.
Okay. All right. Okay. If anyone else has any questions, I think we're good to move on. So now we want to start looking at our columns and dividing every 3 columns. So it's pretty much the same concept, but now we're looking at the indices of each row. So looking at, indices 0 of row 0, indices 0 of row 1, 0 of 2, 3, 4, and so on. Our columns. So now, make sure I'm indented properly. Now remember we have this for loop here for our rows. Now we want to have our columns within this for loop, like in the example in the PowerPoint that Bernard showed us. So for J, and again we're doing the range of the length of BO. Now we're calling 0. And this is telling us that for every index in the list, within the list, BO, when we reach the indices divisible by 3, we're going to print a line separating the column. And so this will be a vertical line now. And this will print out, so it basically, it goes row by row. So it'll print out, in our case, 7, 8, 0. And we're going to say, oh, we want a line here, right in between 0 and 4. And again, and if J is not equal to 0, because again, we don't want a line printing out at the beginning or the end. So if J modulus 3 is equal to 0, oh wait, this goes down here. This is just like earlier. And J is not equal to 0. I'm gonna print, let's add like a space. And we want that symbol there, that line. Not really sure what we'd call that. And now we also want to add here end equals nothing, essentially. And all this does is this is telling us that usually when you print something and then you start a new line. So in the case of our horizontal split, we can print this out and then move on to our next line because we're starting a new row. But when we're in the middle of all our columns, we need to have this end to designate that we're not starting a new line, we are continuing. We don't want to start a new line in the middle of our columns, otherwise that's going to shift everything over and down, and we're going to have only 3 columns and not the 9 that we want. And when we actually print the board out, I'll show what happens when you don't have that included. We also want to say that if J is equal to 8, we want to print out that that row and column location because we're not printing out a horizontal line at the end. We're just printing out that number. So I, J. Here, and I'll add some notes just super quick, just for clarity. So remember that this is a function which takes variable type list, and for every index in the length of our list BO, when we reach indices divisible by 3, we print a line separating. When index divisible by 3 print horizontal line. And same thing right here. When index visible by 3, we're going to print a vertical line. Okay, let's see. Just double checking that everything here is okay so far. And now we want to add an else statement here. So if we are not at a point where the row or column is divisible by 3, and if we're not at a point where the index is 8, meaning the end, our last row or column, we need to print out just that location, that number. Need to print that row and column location. So we'll print, and we're going to print this out as a string. Print string BOIJ. And we're going to add a space here. Yeah, we want to add a space here. And we're going to end it without a new line. Okay, so let's try. Yes, thank you, Bernard. Thank you for explaining that. Yeah, we're adding that space there. If we didn't have this as a string, we wouldn't be able to use the operator, the plus operator, to add a space and continue on. If we didn't have this, and if this wasn't a string, we wouldn't have spaces between all of our numbers, and it would look really, really sloppy. Okay, let's try this out. Print board, and now we can put in board. Our our variable board is our list of lists, and now we can put that in place of BO, because remember that BO is just a placeholder. So if we run this, you see that we have printed out our board. We have spaces in between our numbers, and we have the lines separating in between index 2 and 3, 5 and 6, and again, indexes 2 and 3, 5 and 6. Does this make sense to everyone? Are you able to see clearly? I don't know how clear it is on everyone's screen. Is the Sudoku board clear? Looks beautiful. Thank you.
Could you repeat what the and equals means in line 27?
Yeah, absolutely. So let's get rid of that. So remember that this, I'll add a quote here. End equals this. We're basically telling Python, when you print our line, don't start a new line.
Okay.
Yeah. So if we were to get rid of this and then run it again, you're going to see this is going to get, basically, these first three are going to print, and then it's going to print this line, and then everything's going to get shifted, and we're going to have a really long 3x3. So if I get rid of that,
Gotcha.
yeah, you see that? So
yeah. Yep.
These are all here now, and they're not in their columns here.
Excuse me, a quick question for you.
Sure, go ahead.
Where did you call the function?
Where did I call the function? So the function is called print board now. We've defined it.
Yeah.
We've defined the function as print_board, and so I called it right here. Can you see this on your screen right here?
See where? I can't see it. Can you scroll down for a sec?
Sure. Yeah. Here, I'll try and. Are you able to see this here?
Oh, now, yeah, no,
Okay.
I see it.
Yeah.
I just couldn't see where.
Okay. Yeah, that's fine. Yeah, I just added the print board function right below, right here. So yeah, so now we have our board printed. So now we're gonna.
I have a question.
Could you explain that else block at the last in the for j loop? Sure. So these two if statements here, we have the if statement that is printing the horizontal line. Here, I'm just going to clear that. So we have this if statement here. If the column is divisible by 3 and it's not the first index, we're going to print that horizontal line, or vertical line, which will divide it by 3. And then we have if the column index is equal to 8, which is our last column, then we print that row and column location. So like let's say it's going through the first row and it reaches, I is 0, row 0, and j is column 8. So it reaches this here. And all we want to do, we just want to print that number and then move on to our next row. So a print function in Python adds a new line. And what a new line does is it moves down to the next line. So we don't need to designate this end here. So that's what this is when we don't have a column that is divisible by 3, and we don't have our last column 8, we just want to print the row and column location, add a space to separate from the next number, and then remember that the end equals basically tells Python not to add that new line. Like right here, it adds that new line and goes on to the next line. But if it's not the last column, we don't want to do that. So that's why we have this here. And this is a string because we need to concatenate with, we need to add this space here. We can just straight up print here because we don't have to add a space because there's no number following it. But here we need to make this, and we need to basically designate it as a string within the print statement before we can add this. You can't add the index of a list and a string together. This space here, even though there's nothing there, there's a space there, so it's a string. So that's what this else line here is, and that's why it follows all of these, because it's basically everything in between the columns divisible by 3 in our last column. Does that make sense? Okay. And if I'm going too fast or I'm speaking too fast, just please let me know. All right, so now we have our definition to print board. Print.format BOIJ work. I know that you can do like the enumerate function, and it works the same. It might actually save some space. So if you would like to do that, you absolutely can. But in something as simple as this, just looking at the length of the board and using a range to iterate works just fine. But that would work, yes. Okay, so before we move on to our recursive algorithm, we want to set up a function to find the empty squares on our board. And in our case, we're using zeros to designate an empty square. And we want to make a function that can find those empty squares. And then when we actually start solving for the board, we can know where those empty squares are. We can actually save those like row and column locations. So let's define our function as find empty. And again, our argument or our parameter that we're going to put in is going to be our list of lists again, and we can call it BO again. Because remember, this can be anything, but it's just our placeholder for the for loops, and we'll put it in there. So for I in range, and again we're looking at the range of our length of BO. So length of the board, there's 9 lists, it's going to print 9. A range of 9 is from 0 to 8 because Python starts counting at 0. So we want to say within that range. I don't want to slow everyone else down, but when I print the board, every number is on its own line. How might I solve this? You mean when you run the print board function, it's going to every line? So you're getting like a long column of every single letter?
Like, yeah.
Okay.
The column of like 81 numbers. Or even more than 80 numbers.
Okay. I guess first thing I would probably look at is when you're iterating through your columns, um, for any time that it's divisible by 3 and any time that it's
Mhm.
not, do you have this end equals statement added in the print statement?
Oh yeah, that's what it was. I think.
Yeah, that's probably the first thing I would look at. That might be a culprit. Because like
Is
you
that
showed,
for I and J, or just J?
just J. Because all we need to know for the rows is if the row index is divisible by 3 or not. Because so when it prints the board, if we were to slow it down, like really, really slow it down, it's going to start looking at row 0, are the 0 index of our list of lists, which is this list here. So it's going to go through row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3. That's divisible by 3.
Yep.
Print a line there, and then move on. Print a line.
All right. Yeah, I got the one end, but I missed one of the other ones, or the other one.
Okay.
So yeah, thanks.
Yep, no problem. Okay, so we were defining our find empty function, and okay, we need to make sure it iterates through all of our row column locations until it finds a 0. All right, so for I and range, the length of the board, and then for J, our column, in the range of the length of our row. See, that's giving me a little bit of a... Oh, that's why. So now we want to iterate through the indices of the current row I and just do a simple check if that row and column has a 0. So if board bo I j is equal to 0, then we simply return a tuple. And now we can use a tuple because this is something we want to save. We want it to be immutable. So this is just a simple check returning a tuple with that row and column location. So let's just add some notes here. Finds empty squares or 0. Simple check if row column location is 0. So this is pretty simple here. And the return part, you need to use the print and equals. No, so this is just this here. All this is doing, it's just gonna return a tuple, which a tuple is basically a list, but it's not immutable. You can't change it. So all this is gonna do in this function is if the row and column location is equal to 0, this function here is going to return this value, this tuple, with the row and column values. So we're not actually printing anything. It's just doing a calculation, basically. That's you don't always need to have a print statement in your definitions. It's just doing the calculations, and we can call this later then, so that the program knows where those 0 locations are. And then, yeah, so now we can just add return none here. Are the loops for I and j in sync? So it goes through, it'll go through this row 0 here, so this I. So it looks at I is equal to 0, and then looks at j is equal to 0. 1, 2, 3. And so it goes through each indices of board, and then within that indices of board, which would be, let's say, this list, it goes through the indices of that list. And that's how the list of lists works when we're calling our row, which is the indices of the overall list, and then our column is the indices of that individual list that we're looking at. Does that make sense, Emre? So I guess, yeah. I don't know if I'd say it's in sync, but that's how it looks through it. It looks row at a time, and within that row it looks at each. And so this return none, do you mean length or length 0? It works for either. So I is a placeholder for our current row, and 0 would be the length of row 0, which they're all the length of 1. Okay. After we're done. Yeah, if everyone just wants to answer Ray's question quick, we're just about done with this section, and then Matt will go through the actual like recursive algorithm, which he'll be calling our print board and, more importantly, our find empty. But what I was saying about the return none, this isn't actually needed because a function knows that if this statement doesn't pass, it'll return a none variable anyway. But it's good to have this here just for good practice. Return none, so we know we ain't got nothing. Okay, a couple people are saying they're fine to continue. All right. So is everyone cool if we let Matt take the reins for the recursive algorithm? Is none a Boolean value? None is actually its own variable, I believe. I can correct me if I'm wrong.
Yeah, it's just none.
Yeah.
But if you do
None
not,
Thanks, Darius.
none, it will return true. It's
Oh, that's
just a
interesting.
little weird. Yeah.
Yeah, but yeah. So Bernard will be calling this find empty in the recursive function. I miss you too, Darius. Yeah, sorry I left you alone in choir. Okay, I'm done here. Does anyone else have any other questions about how to set up the list of lists and print the board?
All right.
Okay, no responses. I'm going to assume that means we're good. I will stop sharing, and Bernard, you can take over.
All right. So let me start sharing. Bear with me. All right. So I'm going to paste the code that we have so far that Chris wrote in chat, just in case you guys are like behind and like just want to quickly copy paste it. So there we go. Wait, what was too bright? So as you can see, here's the board. Oh, yeah, I use light mode, Thawny, because I'm old school. All right, so here's what we have so far.
This is going to be in the feedback form. Everyone's going to give you
it's
crap
all right.
for all the light
My
mode.
my Discord is dark theme. All right. Anyways, so here's the here's the code that Chris wrote. It's a little different because I copy pasted it from something else. And so first we're going to go through, we need a function that can check. So, all right, essentially we're going to write a function that is going to guess a number and at a certain position. And we need a function to be able to check this value that we're guessing and to see if it's valid, right? So we're going to have the valid function here. So it's going to have 3 parameters, right? It's going to have the board, which is this list of lists that we talked about earlier. And then it's going to have the value that we're guessing. So it's just a value, and where we're inserting that value. So where this number is going to be inserted. So for example, if we want it to insert here, the position would be row 0, column 2, right? Because it's 0, 1, 2, and this is row 0 right here. So if we want to insert something here, we will pass this position to this function right here, right? So how are we going to check if it's valid? Well, if you remember from the slides, Sudoku, you have to check the rows, then you have to check the columns, then you have to check the box that it's in. So if you could see here, well, this is different, but if you could see here, these 3x3 squares, they, if you remember, it all has to be 1 by 9. I mean, like 1 through 9. And then the rows have to be 1 through 9. And then the columns have to be 1 through 9. So there's just a quick recap of what we're doing. So let us start by doing this. So for this isn't the solver, by the way. It's just checking for the guess, right? So first, we're going to check the rows, and we're going to check each element of a row. So an element of the row is actually the column. So we're going to call this for j in range length of BO 0, right? And you might recognize this from before right here. This is just the iteration through the columns, right? In the row, right? So we're checking the row list, but the element of the row list are the columns, right? So let's do that. So we're going to check the number that we have right here and check if it exists. If it's already in the board, then we're going to be like, okay, well, this is wrong, and we're going to return false. So let's do that. So the board with the position 0, right? Position 0 of this would just be the position of the row, right? Remember? So this position is a tuple that will have the X and Y coordinates. So it would have the X and Y, right? So row, then column, right? So we're saying at this row that we're getting sent from this tuple right here, we're going to check that row, right? So J would be the, we're going to be incrementing the list, right? I mean, we're going to be incrementing the element of that row. So is num, right? If it equals num, then do this, right? So it's going to return false. And there's a problem with this because we're going to be inserting the number. The number would already be in the board. So we have to not check if, like, we're not checking where the board is actually is. Sorry. So if it's in the column, we're not checking the column the number is already in, the guess number is already in. So this is what that's saying. So it's going to have the column here. It's going to return the column here, the column position. And if that is not J, again, the J is like the column positions, right? So if it's not J, then return false. But if it is J, then just ignore this because we're not going to be able to, we're not comparing the number to the number itself, if that makes sense. So as long as the position we are checking is not the position where like we're trying to guess, then we're going to return false. If we find a number the same, if we find the number the same as the number we are trying to put in, this is the number we're trying to put in, right? So let's, does anyone have questions for that? Is anyone still there? I can't tell.
I'm sure I have questions. I just don't know what they are yet. So.
All right. So why? All right. So I got Emre talking why position 1. So position, as if you can remember, is going to be a tuple, right? It's going to be the way we're going to digest it is it's going to be a tuple of a row value and then a column value, right? So position 1 would just be accessing this column value. So you can see it's basically like that. That's what the Python interpreter is gonna interpret. But we're gonna keep it like that so that we can keep doing it for each position. And it's gonna make more sense. I'm gonna go over this code again when I write that where we determine that position tuple, right? Okay, and that's going to be in the solve, but let's worry about that later. So we're going to go through this again, but this time for the column, right? So since it's a column, we're going to check the column elements, right? So we're going to do for I in range length BO. And then we're going to do a similar syntax to this, but it's going to be a little different. So we're going to do if the board position, if the element in the board, and the way we're going to get the element that we're checking is that since we're iterating through columns, we're going to, through the elements of the column, that's going to be the row. And that's I, if you can remember from above. This is going to be the row if you remember from the slides, and then this is going to be the column, right? So this is going to be position 1. And again, that's because of this, right? This tuple contains that column value, and we're going to put it in the column like in this index so that we can access what we're iterating through. So yeah. It's going to be if this is equal to num, then we're going to return false again. But we have the same problem as we had here. And so we have to ignore the position that we already inserted the guess number value in. So we're going to ignore where that row value is already located. Okay. So I'm going to go through an empty board to see if I can ooh. All right. So here we go. So if valid, right? So for J in range length of the board, which is just going to be this 9, basically. So 0 to 8. Is what's going to happen there. If the board value position 0, which is going to be like the row value, J is going to be the row element, which would be 1, 0, 1, 2. So that's J. And then if this number is already, it checks if there's a repeating duplicate, right? So if we find a duplicate, then we're going to return the false. So for example, if I find a 7 here, it's gonna, if the 7, with the 7, right, the position would be position. Can you guys see this? Or is it too like, there, that's better. So the position for this 7 right here is going to be row 0, column 2, right? Let's move that aside. Oh gosh. All right, so it's going to be position is 0, 2, right? So it's going to check. That's going to be our num is going to be 7, right? And then it's going to enter this row loop, and it's going to check the elements in the row, which are these 7, 8, 4, 1, 2. Those are the elements of the row. And then it's going to be like, oh, our num is 7, right? And then the position is going to be, I mean, the board that we're checking, the element board, wow, sorry. The element that we're checking is going to be J. So it starts at 0, right? So J would be 0. And then board 0, 0 equals num. And board 0, 0 would return this 7 right here, right? So it's going to return 7. And it's going to, the if statement's going to check if 7 equals 7. And it's going to be like, yeah, that 7 is 7. And then it's going to check if position 1, which is 2, if 2 equals, does not equal J, where the J right now is going to be 0, right? The J right now is 0. So it's going to be, is 2 not 0? Well, yeah, 2 is not 0 and 7's not 7. So we're going to enter this if, and then it's going to be like, oh, so return false because we detected a duplicate. So we detected a duplicate, so we're going to return false right here. And the same idea goes in the when you're checking the columns here. So does that make more sense to you guys? Let me know how you're feeling.
I have one question. Oh, sorry, go ahead.
Yeah.
So are you going to use solve to see if okay, it's nothing. Never mind. Sorry.
Yeah, the solve function here is going to use this valid command, and the solve function is what's going to determine which position we're passing to this valid command, which number we're guessing to this valid command, things like that. So, but yeah, like we'll get into that in more detail. But yeah, this solve function is going to use the valid command. Where is the input num going to come from? Recursion? Yes. The input num is going to be from this solve recursion function. And we're kind of like making the parts of the solve recursive function first before actually making it. But it will make more sense. So how do you check for the 3x3 square for duplicate number? So that's a perfect question because we're going to check it right here in the checkbox, right? So let's see. So first, we still need to return for the true case. Yeah, we're going to get to that. So like down here, it's going to have a return true. But I'm going to delete that for now because like I'm not going to explain it right now. I'm going to explain it later. Okay, so first we need to find the checkbox, right? So if you can see here, oh, let me just delete. Actually, there we go. Here's a new empty board. And so like we're going to have like a 3x3 box, right? So we have one there. Sorry, I can't draw straight lines. So we're gonna have 9 boxes of 3x3 squares, right? So we need an we basically want to make a way to keep track of that. So first we're gonna be like, so we're gonna find the X position of the box, which is like the 3x3 square. X position of the box. So the position divided by 3, and then the box Y position divided by 0. So inputs divided by 3, right? And so let me explain this for a second. So if we are putting a number in here, for example, right in the middle, right? So this is 0, 1, 2, 3, 4, right? So position would be 4, and then column would be 0, 1, 2, 3, 4, 5. Wait, Am I counting that right? Yeah, sure. 0, 1, 2. I guess that's right. Yeah. So this // is floor division. So // is floor division. So that would be like 7 divided by, I mean, like 5 divided by 3. That's going to return a 1 because it's going to have a decimal here, but we're going to ignore that decimal. So if we bring out a calculator, right, if we do 5 divided by 3, it's going to give us this decimal, but we don't want that because we just want the position of the box. So we're using floor division to get rid of that decimal. So it's just 1, right? So this would just be 1. So our box X would be 1. Oh wait, no, our box Y would be 1. But also our box, maybe this isn't a good example because our box X would also be 1 because 4 divided by 3 is just 1, right? So it would also be 1. So box X and box Y are both 1 for this value, for this specific value right there. And then let's do this again. So if we're choosing this value right here, right? This is 0, 1, 2, 3, 4, 5, 6, 7. So if I copy this again, so we're doing this one. So 0, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Our position would be rows first, then columns. So it's going to be 7. And then our row would be 0, 1. So it's going to be 1. So 1 divided by 3. So our box Y would be 0, right? And then our box X would be 7 divided by 3, which is like, just make, I don't want to screw this up. 7 divided by 3 is 2 something. So it's going to be 2. So our box X is 2. And that makes sense because as we can see here, right? We can see here, if we divide this by 3, right? This is going to be 0, 1, 2. This is going to be 0, 1, 2. So this is going to be 0, 2, right? That box is going to be 0, 2, which is what we have here. Isn't it supposed to be box X equals 0 and box Y equals 2 because pos X is XY? So let me see. Let me see. Declare X position of the box. There's a reason why we're doing it this way, but I don't really know like how to explain it. Oh, it's because when we write the for loop, right? Box X is going to be used in the columns because box X is going to be used in the column indices and box X is the rows, right? And this is going to be the columns. So we're labeling it weird because of the for loop that's about to come up. So let's write the for loop so it's more clear. So box Y times 3 box I times 3 plus 3. And then we have, that's going to be the row indices of the elements inside the 3 by 3 box we're choosing. And then we're going to have 4j in range box x times 3 box x times 3 plus 3. Right. And then that's going to be so this is going to be the column indices. This is going to be the column indices of the elements inside the 3 by 3 box. So what we're doing here is that we're trying to find the numbers so that like these numbers right here, 8. So there's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8. So we're trying to find these values, right? These values, only and only these values. Okay, so if we have a thing here, make that red, make that blue, easier to see. If we have this here, we only want 0, 1, 2, and we only want 6, 7, 8, right? So we only want 0, 1, 2, and 6, 7, 8 if we want to check this box right here. So that box is determined by the position that we are sent. So like if we're checking this position right here, we're gonna have the box over here, the 3 by 3 box over here. But if we're selecting something like, for example, over here, the 3 by 3 box would go over here, right? So 6, 7, 8, and then 0, 1, 2 is what it's gonna go through here. So box X would be 0, and then 0 times 3 is 0. 0 times 3 plus 3 is 3. So for the J is the columns. So, I mean, wait a second. This is confusing me now. Here we go. Yeah, let's just, all right, I'll just keep going because I'm confusing myself by this. Sorry. So if we're selecting a value here, the box is going to move over here. So 0, 1, 2, blah, 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 blah. Yeah, Ray, you want to step in to explain why this?
Yes, of course. So can you guys hear me?
Yeah.
Okay, so basically what we're doing is that we're finding the position of the box in the beginning. So we're saying position 1, which is position 1 came from the column of the tuple, right? Tuple, and then we're going to find modulus of that. So let's assume that, for example, we were at index 6, and then we're going to say 6 modulus 3 is going to give us 0. And then if no, that's going to give us 2. Excuse me, that's going to give us 2. So it means that we are in and if I say that box Y is going to be position 0, that's going to be the row. We're gonna do, what is this called, flat division?
Floor division.
Floor division, and
yeah.
By 3, and we're assuming we're going to stay, for example, at the box where we have in paint, and it's going to be, for example, I'm saying element 1 and 6. So 1 floor division 3 is going to give us 0. So row 0, and then in the column 2, right? And now we're saying for I in range, and we're going to go down there. Yeah, whatever works. Yeah, just don't move it.
Sorry.
So we're saying for I in range, so we're iterating from, so we're getting that box Y that we found, which was the row, right? And we are multiplying it by 3 to go at the actual value, right? Because if we're saying that, because see, the idea is, for example, if we're at index 7, if I do 7 floor division by 3, I get 2. Now, if I get 2, and if I want to iterate within that box now. So what are the ranges of iterating in that box? From 6 to 8 and from 0 to 2. So that is what we are trying to achieve here. So when we say box Y times 3, I'm saying 2 times 3, which is going to be 6, and I'm saying box Y times 3 plus 3, which is the next elements, right? So it's going to be 6 plus 3, it's going to be 9. So we're saying in range 6 to 9, and range 6 to 9 is going to give us elements 6, 7, 8 without like excluding the last element. And Bernard, change the box X, make it columns, and make box Y rows because it's confusing everyone. Yes.
Okay. Yeah. So like we're doing it this way because we're actually looking at the elements of it, right? So box X, the elements of box X are the columns, right?
Yes, that's correct.
And the elements of box Y is the rows.
Yes.
So that's where the confusion, I think, is coming from.
Yes, and for J is the same idea, right? And let's say I'm going to get element 7, 1. So I'm going to say 1 floor division by 3 is going to give me 0. So I'm going to say box X times, which is going to be 0, times 3 is going to give me 0. So I'm going to say from row 0, check up to row 0 plus 3 in that range. So it's going to be range 0 to 2, and if we find the range, it's going to be 0, 1, 2. So I'm saying for I in columns 6 to 8, and for J in columns 0 to 2. Does it make sense to everyone? Okay, I'm assuming yes. So Bernard, keep going.
Okay, thank you. All right, so let's see. So now we're going to check all of those values, right? We're going to check all of those with our num. So we're going to do BO, which is our board, and then IJ, right? So the position that we were talking about, like if we're checking this, if we're checking that, checking that, checking that, and so on, right? It's going to check through all of these 9 values. And if it is equal to num, if there's a duplicate, right? If there's a duplicate, it's going to return false, okay? And again, we have the same problem where we don't want to check the guess number that it's already in. So if the guess number was already in here, we don't want to check this box. So we're only checking the rest of them, right? We're only going to check these 8 elements, okay? So we're gonna type and the position and a tuple of the position that we're checking. So we're checking I and J is not the position that we are sent over here. So does that make sense to everyone now? So that is how we're gonna check the 3x3 squares. Okay. So if these are successful, if these didn't find any duplicates, right? We want to say that this is valid, that this number and that this position doesn't have any duplicates, and that it's a valid like part of a solution, right? So we're going to return true, because if it finds something that's a duplicate, it's just going to escape from these return falses, right? So it's if it finds something that's a duplicate, it's never going to hit here because of the indentation, right? So only after we are successful in checking the row, only after we check the columns, then only after we check the boxes, we're going to return true. All right. So I hope that is, so I'm going to copy paste this to the Zoom if you guys want to copy paste it. Let's just make sure that I have everything correctly. This one, 0, return false. So we can, yeah, so return would exit the function. So if you return something, you can't, you stop like going through this valid function. Like for example, if it finds a duplicate here, then it's going to return. If it finds a duplicate in the column, it's going to return, because you don't want to waste processing cycles checking for a box, even though you already found a duplicate in the column, right? So you don't want to keep wasting your time. So that is kind of what backtracking is about. And so we're going to get into that more when we make this solve. But for now, I want to make sure that everyone's okay. And it seems like everyone is. All right, so no questions, no questions. All right, cool. So now we're going to write the recursive function. This is the thing that's going to get a little complicated, so bear with me if I don't explain it properly. So we need to write the code that uses this valid function that we just made, right? So we're going to need to send the board, we're going to need to send the guess value that we're guessing, and we're going to send the guess value of the position of the guess value, right? That's what we're sending to that valid. So if you could recall from the slides earlier, there's two parts of a recursive function. There's going to be a base case, and there's going to be a recursive call, which is what we're going to call the algorithm. So first, we want to find an empty value that we want to fill in, right? So we're going to use the find empty function that Chris graciously created earlier. It's going to find zeros, right? So we're going to use this. So first we're going to call find equals find empty, and we're going to pass the board into it, right? So we're going to try to find an empty element of the board. And then, so if you can remember, the find function is going to return a tuple ij, or the position of the 0 value, right? So it's going to return that. Or if it doesn't find any empty values, that means it's going to return none. So we're going to use that as our base case. So if not find, right? If we didn't find anything, then we're going to return true. So that this return true is going to make us able to leave our function calls, right? Because since it's a recursive function, it's going to call itself, it's going to call itself, it's going to call itself. But we need a way to make sure that we can leave that function call, or else it will just keep going until you have a memory overflow error, right? So we have a return true there, and that's only going to return true if it can't find anything that is empty anymore, right? So if you can see here, not none is actually true. So if it returns that none, it's going to say, oh, this is true. This is true. And then it's going to return true. And this is going to make a chain reaction of closing each recursive call. And we're going to see where we're going to close that later. We're going to call that later. And then else, if we did find a wrong value, then we're going to store that find tuple into and unpack it with row and column. So this is the position of the empty element of the board that we want to fill in, right? So that this is the base case. This is what helps us escape, right? And then here we go. Let's start the algorithm. So for I in range 1 to 10. So we're gonna, since we're doing a 9x9 board, we're only guessing from 1 to 9, right? So the numbers we're trying to guess are 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So for I, which is I is the guess value, we're gonna guess 9 numbers. We could go through that. And then we're gonna call that valid function we just made to see if this guess is correct, right? So if valid, right, we're gonna send a board. We're gonna send the guess value, right? That's the num, if you remember, that's the num, the guess num. And then we're gonna send the position of that I, right? And the position of that I is actually just gonna be the row column, right? Position of that I would just be row column. So this function just checks one, it checks one element at a time, right? So it will check one element at a time. It will pick, for this example right here, it will go through 1 through 9, right? So is it 1? Is there a duplicate 2? Is there a duplicate 3? Is there a duplicate 4? Is there blah, 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 right? Up until to 9, right? But then we're gonna do, if it is valid, right? We're gonna store the valid guess that we're calling it as I, right? Because we're gonna store it in the list. Yeah, we're gonna store it in the list that we're passing it. So this is why we couldn't make this a tuple earlier, because we want to be able to edit this list. So we're going to store it. We're going to store the element into that position, right? We're going to store whatever we found was valid into this position. And then here is going to be where our recursive call is going to be. So if solve bow, return true. And then I'm just going to finish this because it's easier to explain once it's finished. Bow row column to 0. So it's gonna, what it's gonna do is it's gonna call itself again, right? It's gonna call itself again. It's gonna find a new empty value. So it found this first, right? So it's gonna find this next, right? It's gonna find that second empty value, and then it's gonna store that row and column of the empty value. It's going to go into here. It's going to guess a new value for that element, and then it's going to like if it's true, then we store it. If not, we keep it in. So like this is what is called like backtracking. So it's going to keep entering the algorithm until it finds a dead end, and that dead end would be solved by that dead end would be like if there's a duplicate, and then it's going to go back to the last solve, and then it's going to try another range, right? It's going to try another guess value. So it's going to do this so many times, and it's so fast that we can't even see it. And then return false. I mean, there. And so that's all it is. So I'm going to try to explain this again, just to make it clearer for everyone. So first, we're going to find the empty element or a non-filled element of that board. Then if we don't find one, then we are done. So return true, and this breaks the recursion. This is our base case, right? And if it isn't done, then we're gonna store the empty element into the position that we're filling it in. Then we're gonna guess one of the nine digits that we can put in there. And then we're gonna check if it's valid, if it's a valid. So if we're gonna check duplicates in the rows, the columns, and the squares, right? And then we're gonna check the, if it is valid, then we're gonna store that valid guess into the list. We're gonna edit this list and store that value in there in the 0, right? And then this is the recursive call, and this function will recursively go, and it's gonna keep calling itself over and over again until all slots are filled, i.e. base case is satisfied. So like this is satisfied. It's gonna do it until it's satisfied. Nothing left to guess. And the way it backtracks is with this return false right here. So if this is false, then it's gonna backtrack and then just execute this command. But if it's right, if our solution is right, then it's gonna return true, and then it's gonna return true from the next from the previous call, and it's gonna return true and return true, return true, return true, and then that's what's gonna end our Sudoku puzzle. So let's run it just to make sure that it works. So here we go. So it produced this Sudoku, right? And you saw how quick that was. It was pretty quick, but here's the solved one, right? And it does this recursively. So you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you observe it, it's correct. So that's how we made it. That is how we made it. So is anyone struggling to write this code right here? And this is the beauty of recursive functions, right? Because I can't even imagine how to do this with like brute force, like a bunch of for loops and if statements. But with a recursive function, it's just like 10 to 20 lines of code. And that's pretty cool to me, because it's just going to keep calling itself, and then backtrack. So the solve BO is inside of the if this is if statement, because we're gonna, even if we find like a valid element, right, it could still not be the right solution. So for example, as we're doing this, like we have so many possibilities of filling this row out. And if we fill this as 1, that doesn't mean that that's the right solution right away. So it needs a way to backtrack. So it's going to check if this is where it's going to call itself to check if that certain solution, if that branch of the solution is the correct one, right? If it's the dead end, it's going to undo everything. It's going to undo everything, but with the board equals 0. So it's going to go back until it tries another digit, until it tries, for example, we tried 1, right? So it's going to try 2, and then it's going to try 3, and it's going to keep going to the dead end, going back until it hits 5, right? And that is like the start of this branch right here, of this branch. So there's a lot of branches that it can go through. So we're trying to find this successful path right here. That's what we're trying to find. But first, with the backtracking, we're gonna hit a lot of dead ends. We're gonna hit a lot of dead ends. It's a lot. So to test it, we have the print board, right? And then we're going to solve it. We're going to solve the board. And then we're going to print a line just to like separate them together from each other. Make that longer if you want. And then we're going to print the solved board. And since the board is being edited, we can just print the board again. So this is make this clearer, like print solved board below, and then we can run it again, and then there's your solved board. There we go. So here's the code again for the solve. If anyone needs to copy it. So yeah, the main takeaways is that recursive functions are useful in certain applications. This is one of them. And in a recursive function, you have a base case and then the algorithm. The only thing I'm getting is true. What do you mean by that, Amber? Like it's printing true? Yeah, I'm not sure where. Like when you print board, it says true. Here's our code. Oh, maybe did you have to print parts?
Emre, did you return false at the end of the solve function? Okay.
I wonder where that could be possible. Yeah, so I'm gonna upload this source code real quick. So paste bin. I'll upload this and then you guys can take a look, because like Zoom does a weird like character limit thing. So here's the paste bin for it. But does anyone have any questions about what we just did?
Not at the moment, but I'll let you know if I have any.
Okay.
How hard would it be to like have this to be able to put in like real Sudokus from like a website full of them and have it just read them and solve it?
I'm guessing we'd have to like write a new function. So like maybe you can download the Sudokus in a text file, like some sort of like CSV file, and then write a function to read the file and then like put it into this format. That would be a added work, but yeah, that would be interesting. Like just seeing it. And yeah, you could also try making it in a GUI. So like Python has Pygame, and you can like physically input the buttons and stuff and just type the Sudoku puzzle that you have. But if you want to test like another Sudoku puzzle on this and use something else, I would just edit this. I would just edit this list that we have. So like, for example,
Yeah.
But yeah, you could automatically do it. That's like the beauty of Python, is that you can automatically do it with something like that. Make a Sudoku generator next. Yeah, that'd be really
Be
That
interesting.
would be
fun.
interesting. Yeah. Someone actually at the very beginning mentioned trying to use like random int to make like a board 1, a board 2. But you know, like Bernard said, that would be like an additional function to add. Yeah,
I would
we'll
show
review.
up for that, for the record. A Sudoku
Really?
generator
That's
workshop.
good. Yeah,
Yeah.
we'll have a feedback form at the end. So if you have any suggestions or like compliments or anything, like, you know,
Sounds
feel
good.
free.
Yeah.
Yeah, that would be interesting. Oh, you're welcome. Have fun at your meeting.
Have
I'm
fun.
glad you had fun here. So here's the solve function. Okay. Is everyone done with the code?
My stuff is printing dashes every third line.
If you're printing every third line, that would, you said dashes every third line.
Yeah, like,
I would check probably your print board function, and I would check where it says if j modulus 3 is equal to 0. I would check in the print function if you have that end equals quotation marks. So is it like printing to a new line? So do you only have 3 columns, or when you say that there are lines across every 3 columns, is that what you mean?
my first and third columns, I have like a dash, then numbers, then another dash, I think. Can I put the picture in the chat?
Yeah, absolutely.
Okay.
And feel free to I would say it's probably in your print board function. Feel free to copy and paste that block of code in chat as well.
All right. Do you need to see the print board function?
Yes, please.
Here it is. I'll also paste it in chat. All right. I'm gonna share the PowerPoint now. So let's reposition this. So we did the creating the Sudoku board, and then we did the recursion, right? We did the coding. So right now we have some important news to share. And let me present because it looks weird right now. Oh, geez. Present. Here we go.
Okay, so I hope you guys had fun today. If you have questions, like always, send us an email or something. We'll be happy to help with the code or something. But so some important news. So basically, if you attended our GBM, we need committee members, and we don't know, for example, there's workshop committee and stuff. But there are, if you join if you go at our link tree, you can find links about the committee membership form. So you can go there and see, you can go there and see basically like all the committees that you can apply to and see what interests you. If you have questions for any of them, please feel free to send me a message and I'll send a reply and like redirect you to people that actually are in the committees. We have some upcoming events. We're gonna have a Lockheed Martin info session event, October 19th. This is gonna be in cooperation with SWE. We're gonna have an SOE info session, and it's also gonna explain how a technical interview is like. And we have a very exciting event. It's going, I don't know, it's going to be kind of interesting. It's going to be a virtual dance party. So I think it's going to be fun. So please come join. I mean, we try to make it fun. So, and also every link is here in the link tree. So please use that. You're gonna find there everything for our next events, basically. And lastly, go to the next slide. We have, please fill our feedback form. It really helps us a lot. And for example, if you want to see a next workshop, maybe on Sudokus, like we'll try to come up with something interesting, maybe come up with a graphic user interface to like how to put our Sudokus there automatically instead of like writing in the board, or I don't know. Like, please let us know how we did, what can we do better. And if you have questions, always you can contact us. Right here are the emails, our emails. And lastly, a huge shout out to Chris and Bernard. Great job today, and thank you a lot. Claps in the reaction.
Yes, absolutely.
Yeah, this is both of our first times presenting, so
yeah.
And lastly, if anyone wants to play Scriblio, or like, I don't know, we can separate in break rooms or something, and we can play some games.
Yeah.
I'm stopping the recording here, and thank you for attending.
Yeah. Wait, I just wanted to